We now discuss the solution of a problem from the section coordinate geometry. The problem is based on the concepts of circles. This question has appeared in the joint entrance exam main held on 26th June 2022 in the first shift. The given question is, let C be a circle passing through the points A with the coordinates 2, -1 and B with coordinates 3, 4. The line segment AB is not a diameter of C. If R is the radius of the circle C and its center lies on the circle x minus 5 whole square plus y minus 1 whole square is equal to 13 by 2, then R square is equal to, we are given 4 options. Option A 32, option B 65 by 2, option C 61 by 2, option D 30. So we are given a circle C which is passing through the points A and B, and it is given that this line segment AB is not the diameter of the circle C, and if R is the radius of this circle C and its center lies on another circle x minus 5 whole square plus y minus 1 whole square is equal to 13 by 2, required to find the value of R square. That is the given question. We now discuss the solution of the problem in detail. We have a circle C which is passing through the points A with coordinates 2, -1 and B with coordinates 3, 4 with radius R. That's the circle C passing through the points A and B. It is given that the line segment AB is not a diameter of C and hence it will be a chord of C. This is it's not a diameter, it is the chord of C. Now we find the equation of AB using the 2-point formula for the straight line. A x1 y1, B x2 y2. Then the equation of the straight line is given by y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Now substituting, x1 is equal to 2, y1 is equal to -1, x2 is equal to 3, y2 is equal to 4. We get this, and on simplification we get the equation of the line segment as 5x minus y minus 11 is equal to 0. We are given another circle S given by x minus 5 whole square plus y minus 1 whole square is equal to 13 by 2. Clearly, the center of this circle, let's denote by E. It will have the coordinates 5, 1 and its radius is under the square root of 13 by 2. So, we do not know where this circle S will lie and how this will lie, we do not know, but we will put a E. E is 5, 1. That is the center of the circle. Now, we want to find the perpendicular distance from the point E on to AB is EM. We draw a EM, perpendicular distance EM, and this length of the EM will tell you whether this line segment is intersecting S, or is it touching S, or is it outside S. So for that reason we want EM. Let EM, the length of the perpendicular drawn from E on AB, is equal to the AB equation we know, and the point 5, 1 we know. The perpendicular distance formula we will apply. That's equal to, that is the perpendicular distance. The perpendicular distance is this one. Now use the formula modulus of 5 into 5 minus 1 minus 11 whole by under the square root of 5 square plus 1 square. That is 13 by under the square root of 26, that is equal to under the square root of 13 by 2, which is equal to rho. So this EM, the perpendicular distance drawn on AB, is exactly equal to the radius of the circle S. Therefore, the circle S we continue in the next slide, and we have the circle S. It's a center, it's a radius. So we have EM is equal to under the square root of 13 by 2, that's equal to rho. So this shows this AB, line segment AB, touches the circle S at M. This is the circle S at M. Agreed. Now the question is, where is this M? M is on AB, is all right, but how it is? We claim that M is the midpoint of AB. Here many people take it for granted, M is the midpoint of AB because it is looking like that. But our concern is not that one. We want to teach mathematics with a rigor. Therefore, we will give you a proof for that. So we claim M is a midpoint of the line segment AB. Now consider the right-angled triangles AEM and BEM. AEM, BEM. So these are the two right-angled triangles. Now we will show that they are congruent. How? Now angle AME is equal to angle BME is equal to 90 degrees. Agreed. AE is equal to BE is equal to under the square root of 13, which is equal to hypotenuse. How do you know AE? The coordinates of A are known, E are known. So distance formula you apply, and B, coordinates of B, coordinates of E are known, distance formula you apply, you will get root 13, they are equal. And EM is equal to BM, we have already concluded that M is the midpoint of it. So therefore EM is the common side. So what is that we got? A right angle, this is 90 degrees, hypotenuse, AE is equal to BE, and the side EM, RHS property, right angle, hypotenuse, side property, they are congruent. Therefore AM is equal to BM. AM is equal to BM will tell you M is the midpoint of AB. Agreed. What will be AM? The length of AM is equal to length of BM. What it will be? The length of the line segment AB by 2. And again, the coordinates of A and B are known. They apply the distance formula. The length of AB will be root 26 by 2. After cancellation, this will be under the square root of 13 by 2. So M is the midpoint and AM is equal to BM is equal to root of 13 by 2. Agreed. We continue in the next slide. So that is the situation there. Agreed. Now we extend ME to meet the circle S at D. So this is the D point. Now our claim is the point D that lies on S is the center. Then it will be MD will be what? ME is the radius, ED is the radius. MD will be 2 times rho, that is the diameter of the circle S. So that will be 2 times under the square root of 13 by 2. Rho is root of 13 by 2. So MD. So we claim D is the center of the circle C that lies on S. We claim. Now the students take it for granted that it is looking like that, therefore they take it. And thereby their answer will be just in 4 or 5 lines they will get. But our concern is to talk about to bring the solution in a mathematical, the correct mathematical way. Right. So how do we prove D is the center of the circle? So we consider right angle triangle ADM and BDM. Agreed? So this is ADM, BDM. Now angle AMD is equal to angle BMD is equal to 90 degrees. Agreed? AM is equal to BM. Just now we have seen M is the midpoint of it. AM is equal to BM. We have already seen. And DM is equal to DM common side. So we apply SAS property. Therefore, by this property, they are congruent. When they are congruent, this AD is equal to DB, DA is equal to DB. This implies C is the circle with the center at D which lies on S with radius R is equal to DA is equal to DB. That is the circle C. So what is that we want? We want R square. And we take the right angle triangle ADM and the hypotenuse is R. R square is equal to, use the Pythagoras theorem, R square is equal to AM square plus MD square. In the right angle triangle ADM, R square is equal to DA square is equal to AM square plus MD square by Pythagoras theorem. And we know what is AM. AM is root of 13 by 2. Root of 13 by 2 square plus MD. MD is the diameter of S, that is root 26. Root 26 square. So when squared, it will be 13 by 2 plus 26. Taking the LCM and simplifying, we get 65 by 2. So thus we got the answer for R square. That is what is required in the question. So let's look at our options. Our answer 65 by 2 appears against option B. Therefore, the answer to this question is option B. That is the detailed discussion of the solution of the problem on the concepts of circles. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.